Anyhow, just so everybody's aware, this is what? Math 1033 to the computer system, but to all the other legends on the planet, it's Calculus 2. So this course is essentially a continuation from last semester. As I said before, I am not going to why is it doing that? I don't plan on, what am I saying? Losing my mind. Yeah, the syllabus is on Canvas. You won't see Canvas until later today. Please read it. Part of your first homework will be questions about the syllabus, right? So a couple important things I want to point out that I think you should be aware of before we begin. And by the way, for those of you who weren't with me either in the spring for Calc 1 or in the summer for Calc 1, just send me an email so I can catch you up, because more of you were with me, and I don't want to waste valuable time in that sense. So let me try to make that extremely clear right now. So if you weren't with me in the spring or the summer, send me an email if you have questions. And then we're going to hit some of the important stuff about the syllabus right now. So let's do that. Well, first, the other thing I wanted to say is if you want to go fully virtual, email me, or switch groups. Someone might say, I want to be in group A or B. If you would like to switch or you want to go fully virtual, that's fine. If we have enough seats, you can even come in person each time if you want. So if you want to come in person both days, shoot me an email. I will try to meet everybody's needs. Obviously, we have priority. The priority would be anybody, you know, if you all go virtual for everything, then I'm going to be like, what the heck? I have no friends. But, you know, in my other classes, it seemed like there was a fair amount of people that wanted to come to both days. There was a fair amount of people that wanted to come stay fully online. So if you have a preference, send me an email. We'll try to make it work. I understand this isn't the most ideal scenario. It's better than what we did over the summer, I think. Well, I don't know. You guys will be the judge of that. Was summer bad or good? What were your thoughts on it? Anything? You could be honest. I won't be. I mean, we put it together in like 3 weeks, right? Okay, yeah, you're honest. That's fine, yeah. We did our best. Okay, does anybody have a question about logistics? What day they should come? Remember, this is a 4-credit course. You're supposed to be here Tuesday, Thursdays, and Fridays. I don't want to be here Fridays either, but we got to do it. Yes. Yeah, so that's a good question. The question was on Fridays. Yes, we have to split up. So the way I would guess we should do it is this Friday's Group A. I'll send emails every week to remind you guys. And again, if there's a preference or there's something you would want me to try to accommodate, I will do my best to do so, you know. And the other thing I will say is, I know some of us might be annoyed by all this. Some of us might be concerned. Everybody has a different opinion on this. You get the one thing I'll ask that everybody just respects everybody else's opinion. That's all. You can, you know, however you want to feel about it. You know, I got people in my circle at home. My sister-in-law thinks everybody's going to die. You know, I got friends that act like there's nothing wrong. So everybody has a different opinion on this. So just try to respect everybody's opinion. You know, and be adults. That's what I'm asking. Right? And hopefully we're done with this after this semester. Please, whoever, Allah, Jesus, whoever, Buddha, someone. These are the times where I'm always like, where are you guys at? Right? And then someone says, you shouldn't say that. I'm like, but where? Okay. Those people say everything happens for a reason. All right. So a couple things I want to point out that are important. I know I got some emails. I forget if it was Becca or you or Cammie or whatever. One of you emailed me about the book. You don't need a new book. If you have the calculus book already, keep it. If you don't, if you have the My Math Lab already, you don't need to buy it again. In fact, the calculus textbook should work for calculus 1, 2, and 3 if you guys end up taking calculus 3. So one of the things I would like to hit on right now is the book. So just remember, the book is not required, but as you'll see on the syllabus, but I am encouraging you. So you can either get a pay for the book, you can buy a digital code, you can get a free version on some illegal website. I don't care how you get it. I encourage you to get one. I will never assign problems from the book. You guys who've had me before, I'm not going to say do problem 2 in section 5.9. But what I will do is I will expect you to be reading a calculus textbook along with the lectures. That's how you learn it. You should do the problems in the book or find a resource on the internet. There's good free resources on the internet too, by the way. Now, just like last semester, if you have the access code, I will put problems on My Math Lab for extra credit. So, and by the way, if this is confusing, say to you, Eric, you just see me after class, send me an email, we can explain it all. So I'm assuming at this point, everybody's sort of familiar with these My Math Lab type things. They have them for every subject. My Math Lab is really good, but I'm not going to force you to buy it. I have a hard philosophical problem with how much money books cost. I know why they cost money. It's not that there's a bunch of people getting rich. Think of all the nerds that have to sit around and do software engineering to give you My Math Lab. That's why your book's $300. Right? That being said, I'm not going to force you to buy it. No, Alex, there is not. I didn't put anything up yet. So the question was asked by Alex if My Math Lab's up yet. There's nothing up yet. Not even a syllabus. I don't think I posted the syllabus yet, did I? No. Although I should start doing that because I get emails. I never put it up before because you guys would email me about questions that I was going to talk about in class. And then now you email me and say, I can't see the syllabus, so I can't get on Canvas. I'm damned if I do, I'm damned if I don't. Okay, so does everybody understand the book stuff? We cool on the book? Look, the book, there's a copy of it right there. It's big, it's expensive. But, you know, if it were me, I would buy the book, but I'm just not going to force you to do it. I know it's expensive. And by the way, if you have a textbook from a friend or a relative, and maybe it's a different book, maybe it's another author, it's most likely going to work. Almost every calc book's the same damn thing. So keep that in mind. Okay, any questions about the book? All right. So if there's no questions, I'll check the old chat now. Okay, so then the next thing you guys are always concerned about is your grades. I have changed this slightly this semester. I think you'll not be annoyed. I think it'll be good. Your grades are going to be, and again, the details of this are on the syllabus. But your grade, it's going to be weekly homework again. So you'll likely have 15 of them. But what I'm going to do is I'm going to have a Canvas portion. So these are going to be written. And ideally, you'll scan and upload it. Just like we did in the past. Usually you would hand these to me in person, but I think the people would prefer that you don't do that in light of germs. So if you can scan and upload. For those of you who aren't familiar with how to do that, it's really easy. Any of those printers on campus that you're allowed to use, it's free. You can email yourself. You put it in there, you hit the email button. If you have a smartphone, it's free to do on a smartphone now. So every smartphone has it built into its Notes app now. It's not hard to do. But if you do have issues with that, you got to reach out to me. Okay. So that's one thing. Now, the next thing we're going to do is slightly different. I'm going to have what I call weekly quizzes. And these aren't going to be difficult or hard. But they're going to be short little things. Basically, every week I'm going to ask you to answer a couple simple questions on Canvas. It's not going to be difficult. It's basically going to be a way for me to keep, hopefully, you guys paying attention and at least accumulating some points. Is that all right? Because if you thought Calculus 1 was hard, this is even harder. So this is probably one of the more difficult classes most of you will take in two respects: difficulty of material and quantity of material that you're going to be asked to learn. And then you're also going to have a midterm and a final. So instead of 3 exams, you're going to have 2. And they will almost certainly be like they've been in the past. Here's a test. You have a day to do it. So if you've never had me before, I hate big tests that you sit in class. I hate multiple choice tests. Your test will likely be 5 to 10 problems. You get a day or so to do them. Open book, open notes, use the internet. Most of you will lose points because you don't know how to properly write solutions or credit your Wolfram work, essentially. So that's how your grade's going to be determined. Anybody have a question about that? Comments? Does anybody have any questions or comments? But just out of curiosity, did anybody watch the videos over summer? Like, were you guys watching them at all, like on the YouTube thing or anything? Or you don't? You could say no if you weren't. I'm just curious. Did you? Okay. Yeah, I don't know. I mean, because I'll put them up. I just, if no one's going to watch them, I'll put them up. It's actually a pain in my you-know-what. It is funny because, like, all here's a chat. Someone's chatting on the ones. Oh, okay, yeah. So some people are asking what videos. What I was doing over the summer and in last spring is all these Zoom lectures were being put on YouTube. So I'm happy to leave it up there. I'll just start doing it. I don't really care. I'll do it for you guys because I love you all platonically, of course, as you know. Okay, good. All right, well then, unfortunately for us, since there's not much else to say, we get to start doing math, right away, which is good if you're a math nerd like myself, and it's bad for those of you who are fearing for your lives. So let's get to it. What is Calculus 2 about? So what is this? Well, the easy answer, which is kind of boring, that doesn't make any sense. Easy, easier. Is that it's a continuation of last semester. But that's really sort of a generic and boring answer. I like to sort of be more descriptive. For me, it's about integration and approximation. Those, to me, are the big themes. And they're also two of the more useful and applicable tools, that we want you to get from this class. So let's be real clear. I mean, I'm not a fool, and I'm not going to sit here and lie to you and think that you guys are fools. Much of what we do in this class, and in most classes, you're going to forget certain things, like procedures we learn, problems we solve. You're going to forget them. And even if you don't forget them, most of you are going to go into careers where you don't use any of these things. And that's fine, but it's not really about the procedures. No one cares about the procedures. In fact, many of you know that most of the procedures you do in this class can be done by software now, right? But what we need is we need people that understands why and how these procedures work. And not just why and how they work, but how can you take what works for one particular scenario and adjust it and modify it so that it's useful somewhere else. So how do you take something that we do in here, say how we integrate certain functions, and how do those themes apply, and how can they be used elsewhere where it's maybe not so obvious? So that's kind of what we hope you guys will get from this class. But you're only going to get from this class what you put in. So when we say it's about integration and approximation, we might as well jump right in. These are things that you should ponder, and I'm going to ask you to do it on the first homework. I asked you to do this on the final. Many of you just muscled through some weird words, didn't really make sense of it, which is fine. I should sort of, I would be remiss. I'd be kind of a jerk if I didn't give you guys full disclosure. I've shared this with some of you before, probably not all of you. One of the things I did as a student is I saved all my work in all my classes. I used to have 3-ring binders like your red one right there, and I would take notes, and I have boxes at home, all my undergraduate crap, all my graduate school crap. I have boxes and boxes. And it's funny, the one day I went through my Calc 3 binder, and I'm reading like my homeworks in like the professor's comments and like the exams, and I realized I was just as foolish and knuckleheadish as you guys were. You write things that you don't even know what the hell you're writing, but they sound good to you, so you write them down. And then when you read them as a professional now, I'm like, what the hell was I writing? I sound as bad as some of you guys. I'll say define something, and you guys don't define it. Like my favorite thing in Calc 1, I say use the definition. You will not get credit unless you use the definition. You know what half of you do? Say the hell with the definition. I'm not using it. I'm just going to write down whatever I want to write down. It's like you don't even proofread things. But anyhow, I used to do the same thing, so I won't hate you too much for that. But you got to remember that this stuff is hard. It's going to take a big effort on your part. And some of you, you're going to say, is that effort worth what I'm here? And I don't know. I can't answer that. Only you guys can answer that for yourself. Unless you're some, one of the 1% of these geniuses out there, you got to jump through these hoops if you want certain careers. And here we are. I don't know. I prefer like my surgeon to have once had to learn how to integrate as opposed to some other thing they might have asked you to do, right? You want someone cutting you open if they couldn't figure out how to integrate by substitution? I don't know if I want that. All right. Anyhow, let's pick up with that then. So let's recall some stuff. And this is very important. If we write this symbol right here, this concoction of symbols, this is called the definite integral. Of f on the interval a comma b. This is the name we give to that symbol. Now, here's the subtlety that's extremely, extremely important. And this is what many of you fail to understand and appreciate. How is it defined? It is defined as a limit of what we called Riemann sums. So if we remember what that means, it means this. The actual definition of this thing is the limit as n goes to infinity of this scary looking creature. And what makes this hard to learn is that we throw it down your face at the end of Calc 1. And so what typically happens is that students at the end of Calc 1, you're burned out because the semester, you're also this, not as there just a new topic thrown at you, but there's new notation. There's these shorthand notations, and there's all this stuff at once that just kind of dropped on your head. And what happens is a lot of times we get discouraged, or we give up, or we just say, whatever. But I cannot emphasize enough how important I believe it is that you suffer through understanding what does that little k mean there? What does that subscript of k? What does that mean? You'll remember that, hopefully, that f evaluated at x of k, we motivated this using rectangles, the height of a rectangle. And then that delta x is the width of these rectangles. And so what this limit is really saying is we're going to approximate, the motivation at least, is we're going to take a region in the plane and we're going to approximate it by rectangles. And then what we recognize when f is continuous is that as the number of rectangles increase, we have a limit that happens. And so we give this limit a name. Now, computing integrals by this definition is very difficult. We did that in Calc 1. It was a complicated thing. Many students don't fully grasp it, and that's understandable. It's a hard concept. And then what happens is we then prove this powerful theorem called the fundamental theorem of calculus, which takes that difficult definition and allows us a very simple arithmetic procedure. And so this is where students get confused. You guys confuse the definition with the big theorem. So we have to be clear about this. We have to sort of remind ourselves of how it's actually defined versus how do we usually compute it in practice. There's a difference. Just like the derivative. The derivative was defined as a limit. However, unless we're in a calculus class, we're always going to use those shortcuts, right? We're going to use the product rule. We're going to use the quotient rule. We're going to use the chain rule. We're not going to write that limit out unless we're asked to do it for a test. Does that make sense? Now, the interesting thing about integration is that is not always the case. There are going to be times this semester where the fundamental theorem of calculus does not work. And we're going to have to remember this definition. Okay, so let's sort of put that into words, I think, so that it's maybe more likely to be stuck up here. So let's sort of remind you of what we mean. So evaluating integrals by the definition is not efficient. In many scenarios, it is more practical to use part 2 of the fundamental theorem of calculus. Now, I'm not going to write all this stuff down because this is in your notes from a previous course. It's in your book. But I hope that you'll ponder these things, and that is the following. So let's remind you of what this thing says. So it says that the integral that we are after, that we're trying to compute, can be evaluated using this simple formula where g of x is any antiderivative of f. So there's a lot of words here, and there's a lot of, I don't want to say scary, but foreign symbols. I mean, don't forget, you know, we're learning a new language. In many ways, mathematics is a language. Calculus is a language. Whether you like it or not, whether it's good or bad, turns out that whatever nature wants to speak, nature speaks calculus. You want to understand how the physical world operates, it's calculus. Okay, so let's do a couple quick examples to sort of build up our, I don't want to say it, maybe our confidence that we know what we're doing. Does anybody want to ask a question? Does anybody want to yell at me? Does anybody want to say, oh, Grady, you wore that shirt like every other day in the summer, but I was sitting at home, so I was going to wear it every other day. I got this new thing where I have a friend who makes t-shirts, so I make math stuff, and then I give it to her, and she makes me a t-shirt. I have all kinds of good ones. Yeah, this is what we do. Well, what is your shirt? You're shaking your head at me. What is that? A soccer shirt. Argentina. They're good. Who do they have? That little guy. Messi, right? So how is Argentina? Let's go into this, and this is an international flavor. I'm always amazed. Like, they've had 2 of these, like, world-class soccer players. They have Messi now, who's, like, not an inch over 5 foot. How the hell can a man that small be one of the best players on the planet? But he is, right? Yeah, right? I don't know much about soccer because I'm an arrogant American who doesn't believe in soccer. I'm just kidding, but that's what they say, right? Football, as the people say. But then they had another guy years ago. What was his name? From like the 70s. Maradona, I believe his name. He's another one. He was like shorter than me. Do you know what I'm talking about? You have a soccer shirt on too? Goodness gracious. What team is that? Oh my God. Very good. Yeah. I always find it weird because, like, in America, if you want to watch soccer, you have to get up at 7 in the morning because it's all happening in the time zones. And then my brother-in-law and all his friends, that's what they do. They go to these bars. Well, not right now because the corona says no, 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 no. But then they sit at home and who drinks beer at 8 in the morning? None of you unless you're 21. Eric, are you 21? Are you? What's your favorite beer? Corona? I see now they hired Snoop Dogg to be their spokesperson. I mean, that is a genius marketing ploy. I saw that last night. I was watching the NBA playoffs and like Snoop Dogg sitting in a beach, but he's in like an outfit that you wouldn't wear to a beach. What a time to be alive. Sometimes I can't believe it. Anybody got a question? Oh, it was great yesterday. Someone dropped an F-bomb in class. And then they sent me an apology. What's that? Oh, yeah, that was good, huh? I was like, he sent me an email. I wasn't mad, obviously. You know, I don't get mad. But I was like, I said to him, I said, some people might be offended by that. That's one thing I've never dropped an F-bomb, have I? No. Was it your class in the summer where Amy dropped an F-bomb on me because the kids were acting up? You should have seen summer calculus was outrageous. My kids were upstairs. The house was about to collapse. It was what a time to be alive. Let's do some examples. What time is this? 2:36. Okay, so let's sort of, again, I'm not going to go into all the details. You're going to have to sort of fill in the missing pieces, but let's do a few. Let's start real simple. Let's integrate from, say, 1 to 4 of the function x squared dx. So a common sort of way to write this is, look, it's debatable how we should properly communicate this, because for some of us this is obvious in the sense that the problem is one line. But for other people it might not be. So the way this is most commonly going to be written in a textbook or in a class is what you say is, what function am I integrating? And in this particular problem, the integrand is x squared. Now, x squared is a simple power function. It is a polynomial of one term. And so if you're in Calculus 2, what you should know just as easily as 1 plus 1 is equal to 2 is you need to know that the antiderivative of x squared is 1/3 x cubed. You got to know that. Now, you're going to say, oh my God, it took me a moment. I don't care if it takes you 20 seconds or 3 minutes. The point is, you got to know it. Now, the way that we normally write this is we put this vertical bar, and then we put our bounds here. And what do these vertical bar means? These mean that we plug in the upper bound first. So this is 1/3 times 4 cubed minus 1/3 times 1 cubed. And if we do the arithmetic, I'll spare you the details. You get 1/3 times 64. What in God's name was that? My ears almost went. Is that a chat? No. Someone trying to enter the room? No. This becomes 1/3 times 63. So we can write that like this, 1/3 times 63. Now, how many times does 3 go into 63? Yeah. Say that again? Yeah, but what's 4 cubed minus 1? See, I'm skipping a step. That way you have something to learn when you get home. You're like, how do you do that? By the way, let me show you a little shortcut that you can do here. It might be worth pointing this out. Let me erase this, and maybe this might be a little easier to see what I was doing. You know that both of these have a 1/3 in them, both terms. So a quicker way you might want to do this is, and you just got to be careful with your grouping, but a quicker way you could even do this is you can just not have the 1/3 there. You can write it like this. Because the 1/3 belongs to both pieces, so you can essentially factor it out, and then you get 64 minus 1, which is 63, right? It's one way to think about it. And how many times is 63 divisible by 3? Well, 3 times 20 is 60. So this is 21. Now, it might be useful if you think about the logic and the reasoning behind each step. Now, if you wrote this on your homework or on an exam, I would be fine with it. But you know, what's more important is why, how. So what reasoning am I using here? Well, this is the fundamental theorem of calculus I used here. And at this point, I am evaluating the bounds. And then the rest of this is just arithmetic. So it's often useful to think about what is the logical development in each problem. So this is a very elementary. I mean, it doesn't get much more than this, but it's worth, sometimes it's the best thing we can do is study the simplest cases. In chemistry, we do that all the time. We beat the hell out of the hydrogen atom because it's the simplest one. Got 1 electron. We still don't know a damn thing about it. Pop quiz. Does anybody know what this H means on my shirt? You should. Chemistry majors, biology majors, right? Huh? Questions about this example? All right, let's sort of gravitate up to a little more involved example. Maybe we're going to integrate. How about we go from 1 to e? This will be fun. 1 over x plus x to the 1/2 plus 4x to the 5th dx. Now, once again, this is an integral where the integrand has 3 terms. Now, all 3 terms in this integrand are very, very simple functions. And I don't mean simple in the sense that like a kindergarten understands. What I mean is, and maybe simple is a bad word. So maybe a better way of saying it is all 3 terms have what I would say obvious antiderivatives. If you're in Calculus 2, you need to know that the antiderivative of 1 over x is the log. You need to know that the antiderivative of x to the 1/2 is 2/3 x to the 3/2. And then you need to know that the derivative of 4x to the 5th is 4/6 x to the 6th. And we're going to evaluate that from 1 to e. So it might even be useful if we want to make sure we don't mess anything up to put grouping symbols around this. So we really don't mess anything up. And so now I'm going to put my bounds in. First thing I get is log of e plus 2/3 e raised to the 3/2 plus 4/6 e to the 6th power. And then it's minus what happens when I plug in 1, which is log of 1 plus 2/3 plus 4/6. I'll spare you the details of squaring 1, or not squaring, but raising 1 to a power. So does anybody have a question about this step? Okay, now we want to try to write this number. This is a number. There's a lot of symbols there, but it's a number. And we want to write down this number exactly in the simplest, at least cleanest, quote unquote, objectively way possible. The first thing you need to understand is that the natural log of e is 1. So this is 1 plus 2/3 e to the 3/2. There's not much I can do with that. Plus 4/6 e to the power 6. There's not much I can do with that. The natural log of 1 is 0, so that goes away. So then I'm left with minus 2/3 minus 4/6. So here's how I'm going to write this number. The way I want to write this number is as follows. I'm going to write it as 1. Then I'm going to write it as 2/3. And then I'm going to I'm factoring that 2/3 out, so it's e to the 3/2 minus 1. And then it's plus, I have a 4/6 in 2 guys, so I'll factor that out, and that's e to the 6 minus 1 as well. Now, that's just how I chose to write the answer. I can't get much better than that. Maybe you go to a calculator and approximate it, that's fine, but I'm going to leave it exact. Now, of course, you might have wanted to do it differently. Maybe you wanted to take the 1, the negative 2/3, and the minus 4/6 and combine all them. You could have done it that way too. So let me say that one more time. There are multiple ways that you can express this answer. I mean, compare that with the first example. The first example, the number was 21. mean, you could write 21 as like 3 times 7 if you want, but that's kind of ridiculous. Does anybody have a question about this? Okay, you also noted that I was very careful with my grouping symbols. I distributed my negatives where they need to be distributive. All that fun stuff. All right, let's look at another one. Those two were what I would call obvious integrals. Now, they're not obvious in that you do them in your head. They're obvious in that the antiderivative should be familiar to you. There wasn't a thought. How do I say this without being offensive? There is a thought process there, but if you're prepared, if you are where you should be in Calc 2, not a straight A student, but just an average calculus student, you should know the antiderivatives for those two previous problems. Now, what Calc 2 is about in the beginning is that's rarely the case. Oftentimes, we got to do a lot of thinking to figure out the antiderivatives. It's very rarely routine. And in many ways, integration is a skill. And it just happens to be one of the skills we want you to learn in Calculus 2. Obviously, we don't expect you to be as good at it to the degree when I was a student. That would be silly. When I was a student, even 5 years ago, machines couldn't integrate. Now machines can. You go to Wolfram, you know this. You go to, what is it, My Way or Mathway or something like that? There's one of the, they'll show you the steps and everything. And that's fine. You should use those resources. But what you should do is think of the bigger picture. Not that you can do or copy the internet's answer. That's fine. I mean, no. It's not going to get you anywhere. What you want to do is you want to be able to take the themes, the logic, the thought process from it. More importantly, what does this integral represent? Now, in the first two examples, I gave no meaning. I just said integrate for the heck of it. But in the right context, this might have meaning. Maybe it's area for something. Maybe it's something else. We'll learn all different contexts for these things in this semester as well. Okay, let's do another one. We're going to have to get into one of the topics that we sort of had to do at the end of last semester. Let's look at something like this. What if now we're going to integrate two x plus 5 to the 10th power? Let's say we're going to go from 0 to 1. Actually, let's make the numbers. Let's go from 0 to 1/2. That'll be more fun. Okay, so now here's the thought process that we have to have. The thought process I have is I say to myself, is this antiderivative obvious? And the answer is not likely. Now, some, excuse me. Man down. The hell did I swallow? How about the one day I was running last week? Nice pace too, 7:27 a mile for 3 miles. Ain't bad for a 40-year-old fat ass. When I say that. But bug in my nose. Started coughing. Swear the damn thing was trying to come out of my ear, tickling my ear. Finally coughed enough. Put some water and when I got spat the damn thing out. I think he lived too, or she, whatever. All right. I don't know what happened. What happens if I get corona? How do we handle that? Food for thought. You guys get to take over. Be like in the Army, if one man goes down, the next man has to get up. Who will take over if O'Grady goes down? You. All right, look, I shouldn't joke about these things. Some people might think this is obvious, but this is not a, hey, look at the antiderivatives instant. It's not 1 + 1 = 2. However, the grouping symbols do, or at least should give you an indication of how to attack. The grouping symbols scream to me that the function I'm trying to integrate is a composition. That screams to me that there's this trick called substitution that we learned at the end of Calc 1, albeit we screamed it down your throat in the summer for sure, and even in the spring. And it is a technique that allows us to take something that almost looks obvious, but not quite, and it allows us to rewrite it so that it is. And so here, the strategy is to replace what's inside the grouping symbols with a new letter. So I'm going to call it y, and then I'm going to set y = 2x + 5. And then the big theorem, there was this theorem called this change of variables, or the substitution theorem. It says, okay, once you do that, now compute the derivative dy dx, which we know is just 2. And then the theorem says that we can sort of take this equation right here and we can rewrite it using what we call differentials. We can rewrite this and treat it as a fraction and say that dx has to be the same thing as 1/2 dy. Okay, so then this term that we cover at the end of Calc 1 says, okay, now let's just replace everything with what its new letters are. So the first thing we're going to do is write the integral sign, but we're not going to do anything with the numbers yet. And we're going to note that this becomes y to the power 10 dy, and then there's this extra 1/2 out front. And then what I like to do is I like to change my bounds. I'm going from one currency to the next. I just got off a plane from New York. I'm now in Lisbon, Portugal. What kind of money they use in Portugal? I've never been. What do they use? The euro there? I don't know. Let's say the euro. I have no idea. I can't use my United States dollars. I got to convert to whatever currency they use where I'm at. So what I have to do is I have to come down here to my equation y = 2x + 5. And I have to ask myself, what happens to y when x is 0? So when x is 0, y is 5. So this guy becomes 5. And then when x is 1/2, what does y become? Y becomes 6. So make sure you understand that step, because if you don't do that correctly, the problem's wrong. If you don't do that correctly, your little rover never makes it to Mars. If you don't do that correctly, there's too much medicine and the patient does not survive. It's funny, you guys think like, this ain't fair. I'm just a chemistry major. I want to be an engineer. Why do I have to take calculus? Engineers, that's all it is calculus. But even chemistry, there's these students. I teach a graduate course in the summer it's a physics course for anesthesia students. They want to be anesthesiologists, the people that put you to sleep and hopefully wake your ass back up. They got to learn physics. They ain't happy about it. I don't make the rules. All right, does anybody have a question about that?
Yes, sir.
Yes, what's up?
Sir, I didn't got it. Like, we just wrote down y is equal 2x + 5. Then we found out dx equal 1/2 dy. Then we put the bound of 0 and 1/2 in place of x, then we found out what the y can be.
Oh, right. So you're doing it a different way. That's not wrong. But if your reasoning's correct. But if you write it, so here, what you're saying is you're doing it a different method. You're saying find the antiderivative in y and then replace it with x, then put your original bounds back in. That's not,
Yep.
That's correct. You can do it that way for sure. I just don't like to do it that way. I like to do it this way. Because what happens when if you take calculus 3 or when you're in physics or other classes, you're going to learn about what are called double and triple integrals. So you have more than one letter. You can't do that strategy when you have more than one letter. You have to do it this way. So this is just my preference. So you're not wrong. You could do it that way. It's just, this is how I prefer to do it. Does that make sense?
Gotcha.
Yep. Okay, cool. So once we do that, then we can, this problem, we've now took an integral that was not an obvious antiderivative. We've rewritten it so that the antiderivative is obvious. Because what does this become? This becomes 1/20th, 1/22nd. Here I am failing class. Can you imagine? If I add 1 to 10, I get 22. Excuse me, I get 11 times 2 is 22. So that's y to the 11th. And I'm evaluating from 5 to 6. And so one way you might evaluate this or plug it in is you might do 122, 6 to the power 11 minus 5 to the power 11. And honestly, these numbers are so big, it might be worth your while to just leave it like this. I wonder if Google will even do that. It probably will round. Let's see. I'm going to check the Google calculator. Those numbers are pretty big, so it might not. Oh, no, it says it did it. You could just leave it like this. That's how I would leave it. But if you want, you could write it as 313,968, 931 over 22. Any questions, comments? Okay, so those are three, in many ways, elementary integrals. So what you need to do is you need to say to yourself right now, how well do I understand them? And you need to gauge how, sort of, think of it as a barometer. If you don't find those elementary at all, then you need to do more practice. If you're okay with that right now, then you're good. You're in the right place. Does that make sense? So from time to time, you should ask yourself, where are you and where should you be? No one's asking you to be able to integrate instantaneously. No one wants you to be a savant and do it in your head. No one's even saying it's worthwhile for you, unless you want to do it for fun as a hobby, to practice this stuff for 5 hours a day. But what we are saying is the three integrals we just did should be obvious for anybody who is majoring in the hard sciences. They should be things that you can readily communicate. These are things that show up on stuff like if you want to go to pharmacy school, you have to take a test. That kind of stuff would show up. You're going to say, well, what pharmacist ever has to do it? That's not the point. The point is you have to prove to learn something, right? That's sometimes the way it works. All right. That was like 5 years ago. I had all these students in the summer. They took Calc 2 because they were trying to pass this pharmacy test at Duquesne, and they couldn't pass it. Then they all passed it. I was so proud of them. They couldn't pass the math part. Now they're all probably wealthy. Although, let's see, if you're a pharmacist at Duquesne, that's like 50, 60 grand a year for 5 years. That's a lot of money you owe, right? And you probably only start making like 60 grand a year in Pittsburgh, which is good money, but still, man. School. Should all be internet entrepreneurs. Walk out of here, get on a plane, fly. Well, now you don't even have to live out there anymore. You can work remotely. Call Google. They're probably hiring. You could call Google and say, Google, I'm really good at going to Wolfram and copying and pasting. They're going to be like, good. That's how we code. We copy and paste other people's code, which is true. Okay, all kidding aside. Any questions? It's funny, there's like a glare on my glass here. And I feel like you're keep raising your hand, but you're clearly not. It's just me raising my own hand. Breaking all the Roni rules. I keep going like this. All right, very good. So, let's say we did a couple examples. Let's think about what are the applications. So, so far integration is useful to us for a few reasons. And these were covered in Calc 1, and we're going to just review them briefly again here. So one thing we can do is we can use it to define area. It can be used to define the average value of a continuous function. So you might not think that's important, but it actually is, because particularly in things like engineering, imagine a very sort of standard example is you have some object, maybe it's a metal plate for the side of an airplane, or maybe you have a satellite or whatever. One of the things, an airplane's a good example because an airplane goes under extreme temperature differences. It might take off in Pittsburgh in the summer, it's 85 degrees, it goes way up in the sky, it's cold, and then maybe it lands somewhere that's cold, maybe it lands somewhere that's hot, it's under lots of pressure, temperature changes. And so we might ask things like, what is the average temperature on the surface of an airplane at a given time? And the way we do that, theoretically, is using integration. We might have a wire that charge runs through, electricity, and we might say, what's the average temperature at any given time of a wire? And the way we would do that is through integration. So the average value of a function is defined through an integral. You might remember what that is. We'll ask you to write it down for homework, and you have to look it up if you don't remember. That's how we learn. How do you learn? You learn by doing, right? It's a good story. When I was 16, I wanted to learn how to drive, and my parents taught me to drive, and my dad would get mad because I never wanted to learn how to work on the car. I didn't want to learn how to change oil because I thought, I'm going to make money one day and I'll pay someone to change my tires and, all that crap. My dad always liked to do that himself. So what did he do since I wouldn't sit down and watch? One day I go to the mall with my buddy. He picks a good day too, the day it's raining. He comes up, follows me up, lets the air out of all the tires. So what we have to do, we got to learn how to change a tire, right? Learn by doing. If I just write the formula down, what good is that? You got to learn by doing. All right. What other sort of application do we have with integration thus far? We had what was called linear. I guess the fancy word for it is I'm just going to call it linear motion. Or more descriptively, we don't need fancy words. Motion along a line. So what we showed is we can use integration to derive formulas for how objects maybe move along a line, or more directly how something goes up and down. The only force on these AirPods is gravity. And so gravity is an acceleration. If I integrate that, I get my velocity. If I integrate that again, I get my function that describes my height. We'll ask you to do some problems like that. You'll mess them up, and then you'll ask me, and we'll do them on Thursday, most likely. That's how it works. You try, you fail, we show you the way. Hopefully you try and fail on all the homeworks, and then when the test comes, you try and succeed. And then we celebrate with Coronas or O'Doul's for you illegals. I always found it funny. That was my argument when I got, not that I condone drinking underage, but we got, we were at a hot party when I was younger. The cops came, we got in trouble because we weren't 21 and had to go to talk to the magistrate. And I ordered, how can I go to war? And I can't drink a beer. He looked at me and said, rules are rules. I was like, damn it, you're right. I got a fine. Although smoking's 21 now, right? So if you were a smoker who was 18, you have to now wait to smoke again until you're 21. Are you grandfathered in? I'm serious. You're not. Really?
Yeah.
That is a shame. Oh, well. We were kids. That's how we bought cigarettes. You'd go buy the cigarettes in a newspaper, and they would just think you say, I'm buying it from my grandfather. Just give it to you. That was in the 90s. Not anymore now, right? If someone sells you cigarettes and you're a kid, they'll like arrest you for that. What a time to be alive. Okay, so these are the applications that you should know how to do. So let's do an example of each of them. So before we do that, let's look very briefly at the area one in a little bit more detail. So here's what we know. So if we have a region bounded by two curves, I'll call one f of x and one g of x. So what you need to do is suppose y equals f of x and y equals g of x are continuous on some interval. Let's call it AB. So if f of x is greater than or equal to g of x, we have a region in the plane. So if f of x is greater than g of x, that just means the graph is above it. So there's a region. So if f of x is greater than or equal to g of x, we obtain a region. And so its area is defined as area equals the integral from a to b of f of x minus g of x dx. And I think I have poor grammar. It should not be it is. It should be it's. Good thing I took the SATs 22 years ago. So someone's chatting up a storm. Now, if you wanted to see why this is the natural way of defining area, it's just a complete and utter generalization of what we did to motivate area to begin with. Draw the region. So let's do that real quick so that you can see. And then if you think about Riemann sums, it makes sense why you might do that. So let's draw an XY axis, and then let's draw two curves. So you might have, we'll call this guy f of x. And so when we say f of x is larger than g of x, what we really mean is that what it means geometrically is that the graph is below it. So this could be our g of x. And so if we have 2 points A and B, let's just call, for the sake of an argument, this can be A, say this is B. Then what we're talking about is the region that's contained between the two. So let's pick a different color. Let's pick, we'll color it in blue. So if I shade this region in, the area of this blue shaded region is going to be defined as that integral on the left. And the reason that's a natural definition is, as I said, if you go back to the Riemann sums of what an integral means, then it makes complete sense in terms of rectangles. So let's do, does anybody have a question? We'll do one quick example and then we'll be done. Does anybody have a question, comment? All right, so here's a typical example, and these ones are a little more involved because you have to do some thinking. So, determine the region, or determine the area of the region bounded by y equals x and y equals x squared. So these problems can come in all different shapes and forms, and sometimes the region that we're being asked to study is obvious, other times it isn't. And oftentimes you have to make some pictures and draw and sketch and think about what information do you have and how can you use it. So for this particular problem, it is very important that you draw a picture. So if I draw a picture, over here, and I remember that these, again, this is one of the things that's gonna be tough for us as students, is you guys have to know these simple graphs. Like, you should know the graph of y equals x looks like this. And you should know what the graph of x squared looks like. The graph of, now let's just say for the sake of argument that this is the point 1, that this is 1. And the graph of x squared comes up like this. Oh, that's bad. And then looks like this. It's a parabola. Now, if you need to go to a calculator to sort of have confidence that you got it right, that's fine. But the area that we're after is just this little petal right here. This is the area that we're interested in. There's no other region that you can argue is bounded by these curves. So you might say that the problem's set up ambiguous, but I would argue it's not, because there's no other region that has its boundary has those two curves. And so how do we compute the solution? Well, the solution says we integrate from 0 to 1, because that's where the region is. It starts at 0 and it ends at 1. And then the upper function is x, and we subtract off the lower of the boundary, which is x squared. And so this becomes 1/2 x minus 1/3 x squared from 0 to 1, which becomes 1/2 minus 1/3. And then for full disclosure, 0 minus 0. And if you figure this out at the end of the day, it's 1/6. So if you have a question, ask. So this is the kind of problem that, depending on another barometer, in the sense of an area question, this is a very simple problem. Now, that being said, if you don't know the appropriate calculus, then this is not simple for you. It's in fact not simple. So you need to, again, think of a barometer. What is your level of confidence with this? You have a question? Yeah. You thought x squared was above it? Not between 0 and 1? Ah, good question. Are you talking about this here? Oh, yeah. Okay, I thought you were talking about something else. So yeah, there is a slight typo. This should not be a 2. This should be a 3. And luckily, in this problem, my error did not cost me. What in the world is that? Luckily, it didn't cost me because it was just a 1. Now, yeah. Any questions or comments? So we'll give you guys some of these to practice. Hopefully you will, and you'll ask questions, all right? Any other questions about this? By the way, is that green hard to read? Does anybody not like that green? Oh, cool. And by the way, before we'll end now, everybody have yourselves a nice day. I hope to see the rest of you guys on Thursday. Please email me if you have any concerns at all about how we're doing things, all right? You're allowed to be honest. I won't be offended. All right, guys, take care. I will talk to you later. Yes, everything will be on Canvas. Yep.